So here we're having a look at the medial and lateral olfactory stria, and actually the primary olfactory cortex as well. So we start with what this is. This is kind of like the inferior view, and you can see the olfactory bulb come here. Now we've already discussed how the olfactory bulb lies within the cribriform plate of the ethmoid bone, and that was like comparing a baby's head to lying in a crib. Now the olfactory bulb, the OB, does indeed lie within the cribriform plate. However, remember we have those olfactory receptors which then anastomosed with the mitral cells. Well, that's what the OMI stands for here, so the mitral cells that are found within the olfactory bulb. So all the green text is actually the unique features that are present within that particular region of the Rhinencephalon or the olfactory system. Now here you can see within the olfactory tract, you can see, you could be able to identify you'd be able to find the anterior olfactory nucleus. Now obviously this is not visible when you look at the dissection of the specimen, but you'd be able to see the anterior olfactory nucleus, and the anterior olfactory nucleus is then connected by the anterior commissure. If I want to recall, like in the last video we discussed the two parts of the anterior commissure, recalling that the anterior part was the part that connected the two anterior olfactory nuclei, and the posterior part of the anterior commissure was the one that connected the symmetric medial temporal gyrus and inferior temporal gyrus. Now in terms of being very straightforward with the actual lateral olfactory stria and the medial olfactory stria, the lateral olfactory stria, actually one way you can remember is L for L. So the lateral olfactory stria does indeed go in the direction of the limit insulae. The limit insulae, where was the limit insulae found? It was found beneath the operculum, and remember we had frontoparietal and temporal parts to the operculum, and actually deep to the lateral sulcus, or deep to the Sylvian sulcus or Sylvian fissure, we found our insula, which was gray matter, and you could also have the limit insulae there. So one way to remember it is that L, the lateral olfactory sulcus, goes in the direction of the limit insulae, and also has, by the way, connections with the temporal lobe. Don't forget that. It actually, if you follow the pathway, it's obviously olfactory bulb, then olfactory tract, and the olfactory tract then gives rise to our lateral olfactory stria and our medial olfactory stria. Now our lateral olfactory stria goes in the direction of the limit insulae, and of course on the temporal lobe. Now obviously its final destination will be different. It will be to the primary olfactory cortical area, which is what POCA is, as well as the amygdaloid body. Now if we go on to describe the primary olfactory cortical area as well as the amygdaloid body, you'll find that this is found actually in a number of different regions, but it's mainly found within the uncus. What was the uncus? It was that terminal part. It was kind of like that terminal part of the parahippocampal gyrus. Now that's where we would find the primary olfactory cortical area. So once again, the primary olfactory cortical area was the uncus. Most simply put, the primary olfactory cortical area is the uncus of the parahippocampal gyrus. Now that is where the lateral olfactory stria would have gone to. What about the medial olfactory stria? The medial olfactory stria also comes, of course, from the olfactory tract. Our medial olfactory stria would have gone to area subcallosa, which is also where you can find your paraterminal gyrus. Now to keep this video short, I'm going to quickly move on now and talk about actually this triangle in this diagram here. This diagram shows how the split of the olfactory tract occurs into the medial olfactory stria, and of course the lateral olfactory stria. And the lateral olfactory stria went into the direction of the limit insulae, and eventually, obviously, the primary olfactory cortex, or the area, and this was the uncus of the parahippocampal gyrus, or and then here our medial olfactory stria actually went in the direction of area subcallosa, where we could find our paraterminal gyrus, What was our paraterminal gyrus? Quick review. A paraterminal gyrus was a vertically shaped gyrus which was found in area subcallosa, kind of anteriorly to the corpus callosum, alright, and a bit lower. Now, another thing to point out is that actually when you have the olfactory tract splitting up into the medial olfactory stria and the lateral olfactory stria, the triangle contained between these two striae was called our trigone olfactorium, or the olfactory trigone, or trigonum olfactorium, olfactory trigone. And this also gave rise to our anterior perforated substance. If I draw it here, this is where our anterior perforated substance would be. And there's a couple of key points here. I'm going to make it kind of like red. I can't find the other marker, but if I made it red, that would have been red because that would have allowed for the passage of blood vessels and important substances. And also the anterior perforated substance, that's where you can also find the special cells known as islets of Ganser Kalea. Islets of Ganser Kalea. Now, before moving on, I also want to quickly discuss the amygdaloid connections. So the amygdaloid connection, the amygdaloid had a cortico-medial part and a basolateral part. I remember the cortico-medial actually had 5 parts and the basolateral part had 3 parts. But for the time being, all you need to remember is that the primary olfactory fibers this time, the primary olfactory fibers went from the olfactory bulb to the cortico-medial part of the amygdaloid body, and the secondary olfactory fibers went from our pre-piriform cortex to the basolateral part of the amygdaloid.